Our 3D printer over here is primarily used for 3D letter channel printing. Now, before we can go ahead and do that, we need to learn the basics of 3D printing and dual color printing. Now, it just so happens that I've just landed a job that lends us a favor that will help us learn the basics before we get to actually printing letters. Today, I have got something quite interesting to do from a customer. Now, this customer makes out these quite cool concrete containers. Now, these concrete containers are poured into a silicone mold, and from there they need to be removed and cured. But the problem is the silicone mold warps a bit, and then you end up getting an oval container. Now, to you that might not be a problem, but for the customer it is a big problem. So they've asked me to come up with a solution to keep that mold from warping. I have got this prototype here that goes inside like an insert that you can pull out, that hopefully will prevent the mold from expanding and warping. Now, I want to do this on our brand new machine that we've got here from AM, which is our 3D printer. I would like to print this from 3D plastic, and we've got a brand new machine from AM to do so, which is our 3D letter channel printer, but we're going to be using it for this idea today. So the first thing we need to do is head over and I'll show you exactly how to design this and how we're going to print it. So let's get to it. So our program that we're going to be using today is something called Tinkercad. Now, Tinkercad is 100% free and is mainly meant for people that want to learn how to 3D draw and possibly use it in a practical sense, like having a printer. And it's an amazing program. It has a community of people. You can always ask for help, and there's tutorials. But I'm going to show you how to create what we've got here in a simple way and actually print with it. So the first thing we're going to do is I need to make this cylindrical one for this mold here. So I'm going to just break out my vernier here and start making some measurements. Okay, so I've got a measurement there. Now, that is going to be our internal diameter, and then we need an external diameter. So either you could measure the item that you need it for, or I've already made something similar, but this one here is a little bit too small, so we have to go a bit bigger. So our first measurement here is going to be 106 millimeters. So what I need to do is go ahead and select our cylinder. We can go ahead and zoom in here, and we now need to adjust the outer diameter edge. So what we need is 106 by 106, making it an actual circle. Now, as you can see around the edges, you don't have a perfect circle, so we just need to round those edges. So we go ahead and we use the sides, and we go to segments, and then that gives you a perfect round cylinder. You could also go ahead and bevel the edge. As you can see, it's beveling the corners, which we don't want. We don't want that at all. We want a straight cylinder. So now that we've gone ahead and we've done our outer diameter, we now need to use the height. Now, all you got to do here is hold down your right click, and then you can move around to see the 3D object from any side. And you can use the scroll wheel to go in and out. So first thing we need to do is move it at an angle like so that we can access this point and see our height. So what we need to do there is use a ruler, and we just need to do 25 millimeters in height. So we go ahead and put in 25, and there we go. Now we've got our outer shape. Now what we need to do is punch a hole in the middle so that we've got a ring. So what we go ahead and do, and you've got different ways of doing it, there's two ways. Either you can go and get your cylindrical shape with the hole already, or you can go ahead and pick another cylinder and then just go ahead and change it to a hole. So what I normally do is, because I want the exact same segment, same smoothness, I'm going to go ahead and push Control, copy and paste. Then what we need to do is get our internal measurement, which is going to be 91. So what we go ahead here and change that to 91 by 91, and you just use the tab button to get to the next one. Then we go ahead and click hole, and we can go ahead and move that into the middle. Now obviously you don't know if that's 100% accurate, so what we go do is we deselect and then drag a square over it to select all of it, and then we go to our alignment tool, and then we can go ahead and align it to the middle exactly between those two shapes. Once you've done that, you can deselect, and we just want the middle, so we select the middle and we make it taller. And by doing that, then you can actually see where it is. Otherwise, sometimes when you try and click on it, you're actually going to click on the outer circle, which is what you don't want. So now that we've done that, we can go ahead, select the whole thing, and we can say group, which is on your top there, Control G. Now give that a few seconds. Sometimes it takes a bit long, but as you see there, it did it quite quickly, and there we go. Now we have our shape that we are looking for, and it's to the right size. This one is a little bit too small, so I have added extra millimeters so that we can print it at a better size. So now that that one's done, we can move that one over, and we can move over to the next one. Now I'm going to just show you how to print this one. This one I don't need to do, but I might as well just do it for you. So what we can do is, because we've already got an outer diameter shape, we can go ahead and just copy the one that we already have. Now if you want, you can always go and change the color to something else so that you don't get confused between the designs that you're doing or the parts, because you could always just go and mold these together to become one, as if you're doing like a BMW badge. So there you go, now they are one mold. But we don't want to do that. We just push Ctrl Z, get our two shapes, move this one over, and now I need something in between that. So all we need to do here is go ahead and select our square, and then we start using our little blocks around the outside to start changing the size. So I don't want this too thick. We're going to go for only 1 centimeter thick, 10 mils, and we just move that to the middle, and we just also make it a bit smaller. We can select both, go to align, and make sure it's in the middle. We don't have to do that one. Clearly I've put it exactly in the middle, which is fantastic. Next thing we need to do is make that 25, so the same height. And now we need something in the middle. Now the reason for having this open cut here is so that when it's inside the mold, I have something to grab and pull it out. So in order to do that, we can go over to our square, and again we make it 1 centimeter thick, and we can change that to 15 mils, and we can go as big as 30 wide by 10. Then we go ahead and we move it in over there, and actually you can make it wider so that you can see it better, because now obviously once you make it flush in there, you won't be able to see it. So let's just zoom in so you can understand, making it bigger so that you can actually see. Now what we want to do is have it halfway. So you just move it up with that little arrow there. We can go ahead and select everything, have our alignment tool, we can have it exactly halfway, and what we can do is make it exactly in the middle there. And there we have it. Now all you need to do is go ahead and group it, and now you got exactly one of these. Obviously that's the wrong size, but that's how you make it. Quite simple. So from here, we're only going to do the one for this video because it takes a very long time to print. So we're going to move that one out the way, and we're only going to have this one selected. And once you've got it selected, you can go say export, and you're always going to use an STL for 3D printing. You can see that you could also use an Autodesk Fusion printing file. You go STL, and then we go ahead and save it. Okay, so now that we've gone ahead and saved that, what we need to do is go over to our Cura program. Now We will make this profile available for you to download and add to Cura so that you can immediately start printing without having to change too much. So from here, all we're going to do is go File, Open, select the STL that we've just saved, and we say Open. And there it is there on the middle of your screen. So now you can go ahead, you can select it, you can go and make multiple copies, you can rearrange. If you've got multiple ones that you want to print, and that's how you do a multiplication, so you just go ahead and select, and you say multiple selected, and you can always go, you know what, I want 5. There you select 4 because there's one already on the table, and there you go, you got 5. Or you can just go Control Z and only have 1. You don't need to have a very fine layer. Because we're using a 0.8 nozzle and not a 0.4, we can use thicker layer heights. So I've selected a 0.25, which is perfect because it gets good adhesion, and because we don't need to sand any of these down too much, and looks is not about everything, it's more about functionality. You don't have to have a very small layer height. So we leave it at 0.25. We're on extruder 1 because remember, we have 2 extruders, we can have 2 colors, but today we're only doing 1. We first go to our quality and make sure that we have got the same layer height in our quality profile section as well as the layer height that's selected there. If you want, you can make this 2 points bigger than normal. That just gives you a little bit better adhesion to the bed if you're having problems with your plastic sticking. But if you don't have that problem and you're using the supplied glue with it and it's working fine, then leave it at that desired height. We're not going to change anything in our walls, top and bottom, but we want to go ahead to our infill and we're going to select here 5%. The reason being is that we do not want too much plastic printed inside here and weighing it down, which is a waste of plastic, purely because this is not being put under any pressure. It is strong the way it should be at 5% infill. Keep in mind that this can withstand over 100 degrees, so anything around that under pressure, it will start warping. So we'll leave it at 5% infill, the rest we're not going to touch. Now obviously it comes down to your material. So the material that we're using is PETG, which comes from AM.CO today, which I highly recommend that you buy the material for the machine because it just works well. So what we need to do is go ahead and change this to 240 or 245 depending on where your printer is. If your printer is in a very cold environment, you need to up the temperatures by at least 5 to 10 degrees. If it's a very warm and humid climate, then you're going to lessen the temperature of your bed and nozzle. So I have a cold warehouse and it's not too cold, but it's cold, so I'm going to use 240. And then your bed temperature, just be careful not to change the initial. You want to change the build plate temperature. That I'm going to set at 70 degrees because it's not too cold yet. Now, from there we can go and collapse that section and we move over to speed. Now, this printer can achieve really good speeds of up to 200 millimeters per second, but remember, the faster you go, the less quality you get. So if you've got sharp edges or sharp corners that aren't cylindrical, then you want to slow down your printer so that it can do those corners correctly and not have plastic bulging out the sides because it's rushing the corners. So from that, I leave mine at around about 150 millimeters. Now, very important, your initial layer speed has to be done at 10 millimeters or less per second. Reason being is that if the printer is printing too fast, you do not have a good first layer and this will not stick, and halfway through the head will knock it off your build plate and then you have a stringy mess which will waste your time. So initially it will be a slow print from the beginning, but as it finishes the first 3 layers, it starts going to 150 millimeters per second, which is what we need. So I normally have my initial layer speed at 10 millimeters per second and I leave everything else the standard. So from there we can then collapse that, then we can move over to travel. Now in here it's very important, this is a very important section that people forget about. When you are dealing with multiple objects on your build plate, So let's say I'm printing up to 2 items, maybe 4. When it goes from one item to the next, you end up having a little string of material that goes between the two every single time it jumps from printing one object to the other. Then it moves up one layer to carry on printing to do both. What happens is that the plastic needs to be pulled back through the machine so that there's no excess leaving a string or a layer between the two. If you're printing something that's moving parts, that will prevent it from moving internally, because you've got little strings or spider webs connecting your 2 items, which you don't want. So what we normally do is we have up to 10 millimeters that it retracts the plastic from the nozzle back into the machine between going from print to print or layer to layer, to prevent a string of plastic arriving around your print. Now, if you're having an issue with that, I would increase not the speed, the amount it pulls back, not the speed. Keep that in mind. Your speed is not something that is too much of a problem. It's more the case of how much it pulls back, because that plastic is molten, it leaves little strings behind. So you want to try and make sure that you get around that. So normally what I do is I select mine at 7.5 millimeters and I leave it at 45 millimeters per second speed to pull it back. I never increase that and I never decrease it. You only increase or decrease the distance. From there, you can go ahead and close that and we can move over to cooling. Now, normally with PETG, you want to have it cool down faster than normal so that you don't have irregular layers. So because the build temperature is so hot at 70 degrees, it actually doesn't cool correctly halfway. It still brings the heat through the plastic all the way to a higher level, and it still stays warm, so it means it's still malleable. So what we want is the fans on the extruder to be at 100% always. And then you can go down as much as going down to your minimum speed, and all of that, leave it at 10 and not try and change it to 100 by mistake that some people do. So we'll leave that like that, and we'll go to support. We are not going to be doing a support purely because there's nothing that needs to be printed in mid-air. So if I can explain that, let's go to our little Yoda over here. Now, if you're looking at Yoda, he's got his 2 ears that are, let's call it, in mid-air. So if we are printing the rest of him, all of this is not overhanging at a certain degree, whereas his ears are wider than his body and they have a possibility of plastic just falling down. Because it's got nothing to print on top of, all the plastic normally just falls. So for this, you would need a support grown from the build plate to here so that it supports the plastic so that you don't have any droopiness. And a good example is right here on the tip of his ear, where it didn't have enough support and it failed and fell. And you can see that just there by the tip of my finger. And that's what a support will prevent. But we don't need that. What we are going to do is just have our build adhesion plate on, and normally I just do a skirt and I do a 3-line count, 10 millimeters distance, and a skirt / brim of 250 millimeters. Now what that means is when this is being printed, what it does first is it prints what you call a skirt, which doesn't attach to this, around the object, which I'll show you while it's printing. That tells you instantly if your layer height is correct. If the nozzle is too far or too close to the glass bed, and maybe you'll have irregular layers and it might knock the print off because the nozzle's too close. So that I'll explain to you once we start printing, but I have that on just so I can change the layer height before it actually starts printing the object I want. So that basically covers all the settings that we're going to use today to print an object like this. So all we need to do now is go ahead and push slice, which is on the bottom right of your screen. And from here, there's a few things that you can go ahead and look at. How much time it's going to take to print that object. So here we see it's 1 hour 13 minutes. Keep in mind that that is an estimate. The next thing you can see, it says it's going to take 59 grams of plastic to print this object. and it's going to use 19 meters of the plastic. Then another cool feature, I've put the price of the roll here in the plastic, and it gives you an estimate of how much plastic it's using and a price on those grams that it's using. Now I know it's in euros, it can't change it to rands, but that doesn't really matter. It gives you a number, you just put an R in front of it and you've got your rand value. So that's quite a cool feature, something just to keep in mind so that you know how much you're using and how much it's going to cost you, especially if you're messing around, or if it's for an actual job. That's your cost calculator right there. Add your markup and there you go. So all we need to do now is go ahead and insert my memory stick, save it to the memory stick, and then we can go straight to printing. Okay, so we're here at our printer. Now I've already gone ahead and loaded some plastic up over there. We're going to be using some translucent plastic today from AM. Now the first thing we need to do is go ahead and warm up the bed and nozzle so that we can go ahead and print our item. But before you do that, we just need to do the settings and then wait a bit, and then once it's ready, it will just automatically start printing after you've selected your print job. So the first thing we need to do is go to Tool and go to Temperature, and what I'm going to do first is do our hot bed or heat bed, and I'm going to leave it on 10 degrees there, and I'm going to plus it all the way to 70 because that's the amount we're going to use. Then I want to click on heat bed here to turn to extrusion 1, and then from there it's easier just to click on ABS, which immediately takes you to 220. From there I can go and make it 240. So instead of having to just keep pushing add to get to that number, we just select ABS and then add what we are missing. From there we can go back and then we can push home, and then that will bring our head forward and get the printer ready to start printing. So we'll just push home and we push all. Now the printer will re-zero and come back to home. While it's doing that, we can go ahead to printing because we've put in our SD card. We select SD card and there is our print job there. Just go ahead and select it. Wait for it to finish auto homing. Once it's done that, we can then say confirm, and then once the temperatures are correct on your nozzle and bed, then you'll be able to see that it'll just start printing on its own. So while we're waiting for it to warm up and the nozzle gets to temperature a lot quicker than your bed, what I'll normally do is take a scrap piece of cloth, make sure it's got no fibers to it, so don't get a microfiber cloth or anything that can leave behind any fibers on that nozzle, because then might go into your print and you'll have a layer separation and then you'll have a failure. So I'm just using some Prolite material that I had from leftover from a job, and all I go and do is go there and keep in mind that it's 240 degrees, so don't spend too much time there wiping. Just do a circular motion, get rid of any excess plastic like here that came off there, because that will end up having a issue when you start printing. So there, just give it a good wipe, make sure it's clean, and then you're ready. So this is our first layer, and this is that skirt that I was referring to. So now this is going to do full ring here 3 times. After that, then it's going to start with the actual print job on the inside around about here. Now again, this is going to be a good indication if your layer height is correct. Now the easiest way to change that while you're busy printing is coming to your screen over here and just pushing on your options panel, and you push options here and you go to Z fine tuning, and then you can up or down your Z axis to either become closer or further away from the glass so that you get a better layer adhesion and a better layer height. So as you can see there, I've got 3.6 millimeters above my bed, and that's the layer height that I prefer using when it comes to doing a 0.8 nozzle and the 0.25 layer height. So I can understand that that might be a bit confusing, that my layer height that I've set to is 0.25, but my Z axis is set to 3.6. What that means is that my layer height, my first layer height, I'm setting from the table. From there onwards, each layer that it goes up is 0.25 millimeters every single time. So it all depends on what height you set first, not the height that it is between each layer on your program, because that will then raise itself every single time it goes to a new layer at 0.25. As you can see now, it is starting the actual print job in the middle. And as I said, I'm fairly confident with this layer height here. I can pick at it, it's not coming off, which means that when it's going to do its actual job, it won't knock anything off and it will adhere to the table. So this is a good indication to tell if you can actually hear it. I'm crapping at it and it's not coming off. Alright guys, here is our finished product. It's finished printing. Now it's a little bit rough on the edges, purely because I sped up the time it took to print this. Now as always, you could get a finer print with less cleaning to be done. And when I say cleaning, maybe a bit of sandpaper, using the included clippers just to get rid of any excess, any strings that may happen. Now you could get rid of all of that by slowing down your printer so it has more time to be accurate. So if you don't have the time, you can always increase that, but keep in mind that you'll have to do a little bit more cleaning. But in this exercise, I just wanted to show you how I made this and printed it and how it came out in the end. So I've got a little bit of things that I need to clean up, but basically the idea is there, and all we need to do is go ahead and slide in our mold just like that, and there we go, job is done. So if you are wanting to see more like this and something a bit more different, then keep your eyes open. We have a few more projects in mind to teach you how to do this, and hopefully I'll be showing you how to print 2 and maybe more colors in the future. So thank you for watching, and keep your eyes peeled for some more cool things coming.